Hello everybody. Our today's lecture is the chemistry comes alive or chemistry of life. You must remember there are different levels of organization in the human body from the smallest to the largest. And you already know that smallest level of organization is the chemical level. So today we'll talk about the chemical level. First, we'll talk about the element, atom, molecules, compounds. What are those small components of the body? All those belong to the chemical level. Then we'll talk about the subatomic particles, isotopes, and radioisotopes. We'll also talk about the free radicals. Then we'll talk about the chemical bonds, different types of chemical bonds that bind the atoms together. Then we'll talk about the chemical reactions, different types of chemical reactions that occur inside the body. Then we'll talk about the organic and inorganic compounds. Both are present in the human body. So we need to know which compounds are organic and which compounds are inorganic in your body. Then we'll talk about the most common chemical in the body, which is the water. So we'll talk about the water and its properties. We'll briefly talk about acids and bases. What are those chemicals? Then we'll talk about proteins, carbohydrates, fats. These are organic compounds in your body. Then we'll talk about the source of energy. So first, to understand the elements and atoms, you need to know what is a matter. Matter is anything that occupies space, and a matter could be visible or invisible. However, the main thing here is a matter must occupy space. So matter can be existed in three forms: solid, liquid, and gaseous. You know that the solid things occupy space. Then liquid, you also know that liquid occupies space, right? Gases are also matter because gas occupies space. How you know? When you put air in a balloon, it gets bigger, right? That means air occupies space. So all those are matters. Now, if you see from the smallest to the largest how the chemicals are built up in your body. So atoms are the building blocks of elements. Then elements are the building blocks of molecules. And then compound, different molecules joined together to form compound. And then the matter or smallest chemical components are atoms in the body. Okay, and elements are the kinds of atoms that we can have. Until today, only 92 different types of elements have been isolated or found in nature. However, the molecules and compounds are many, because these 92 elements can join to each other in many ways to form many molecules and compounds. Okay, so the atoms or elements are expressed by the letters, and we all know that carbon C, carbon atom or element, is expressed by upper block or capital C. So this is carbon. H, hydrogen. N, nitrogen, right? So only with single uppercase letter. If the atom or element is expressed by only one letter or single letter, that must be in capital. Now some atoms or elements are indicated or expressed by two letters. For example, calcium, Ca, sodium, Na, right? So if any atom or element is indicated by two letters, first one should be uppercase and second one should be lowercase. Okay, so these are the atoms or elements. Now molecules. Two or more atoms or elements join together to form a molecule. For example, H is an atom or element. Now if I combine two hydrogen, that is H2, which is a hydrogen molecule. Okay, N2, it is a nitrogen molecule, right? Calcium molecule. So we get a molecule by combining atoms or elements, and that's how we indicate the molecules. Oxygen, O2, right? This is an oxygen molecule. Compound. Different elements or molecules join together to form a compound. For example, H, hydrogen, and oxygen. When these two molecules are combined together, this is water, and water is a compound. If you combine sodium and chloride together, okay, sodium chloride, this is a salt. So this is a compound. Okay, so two or more different molecules or molecules join together to form a compound. Different types. Matter could be many, because you can join the molecules in many different ways and many different amounts. Okay, now if you see the structure of an atom, inside the atom you have subatomic particles, electrons, okay, and negatively charged protons, positively charged and neutrons considered as neutral. Okay, no electrical charge, neutral. So these are the subatomic particles. That means they are present in the atom. Okay. Now, if you see the structure of an atom, this is an atom, and in the center of the atom you have the nucleus, and in the nucleus you have the protons and neutrons. Those two subatomic particles are present in the nucleus. For example, this is an atom and it has 3 protons. These are protons. So positive, right? And this nucleus also has neutrons. So these 3 are neutrons. Okay. So neutrons are neutral. So you see in the nucleus you have same number of protons and neutrons. So in this atom, this is an atom, it has 3 protons and 3 neutrons, equal number. Okay, and the electrons are located on the surface of the atom. Okay, so this is the surface and these are the electrons. So this atom has also 3 electrons, and electrons are negative. Okay, so electrons are negatively charged. Okay, and present on the surface of the atom. That means on the shell. This surface of the atom is called atomic shell. Okay, and this is the nucleus, atomic nucleus. Okay, so nucleus has protons and neutrons equal number, and on the atomic shell you have the electrons. Protons and neutrons are stable, they don't move. However, the electrons orbit the nucleus, that means are circling around the nucleus. So electrons orbit the nucleus, move around the nucleus. So this atom has 3 protons, right? That means 3 positive. One proton is 1 positive, so this one has 3 positive in the nucleus. Neutrons are neutral, so no charge. And on the shell you have 3 negative, because you have 3 electrons, 1, 2, 3. So the atom has same number of positive or protons and negative electrons. That means what? 3 in this one, you have 3 positive, 3 negative, right? So atom is neutral. All atoms are neutral because same number of positive and negative, and they cancel each other, neutralize each other. So atoms are what? Neutral. Okay. Now human body is mainly formed by 4 atoms: oxygen, carbon, hydrogen and nitrogen. So you can say CHON: carbon, hydrogen, oxygen, nitrogen. About 96% of your body mass is formed by these four atoms or by the compounds formed by these four atoms. Some elements are present in small amount or lesser amount or in trace amount in your body. However, they are very important for your life. For example, calcium, extremely, important. If the calcium concentration is low in your blood, that is called hypocalcemia, and that can cause paralysis of the muscles, respiratory paralysis, and the person may even die. So you see, although present in a small amount, but is very important for your life. Phosphorus in a small amount, potassium, sulfur, sodium, chloride, magnesium, iodine, iron. So these are very important, although they are present in a lesser amount in the body. For example, another example, iodine is essential for the thyroid hormone. Synthesis of what? Thyroid hormones. And thyroid hormones are very important for the metabolism in the body. Hypothyroidism. If the thyroid hormone is less produced in the body, that will lead to hypothyroidism. It is a clinical condition. If the thyroid hormone amount is more, that is hyperthyroidism. That is also not good. So you see, normal amount of iodine is very important for your body. Iron, you all know that iron deficiency causes anemia, a clinical condition, right? And that can cause serious problems in the body. So those are some elements present in the human body, and these four are very important because about 96% body mass are formed by these. However, these are also important. Those are present in a small amount in the body. Okay, so now let's go back to the atoms. You already know that atomic nucleus and atomic shell, and you also know that the electrons are on the shell and protons and neutrons are in the nucleus. So electrons are present on the shell and protons and neutrons are in the nucleus. So like these are the protons and these are the neutrons. Okay, so this one has 3 electrons, 1, 2, 3, negatively charged, and this one has 3 protons, that means 3 positive. Okay, 3 protons, and neutrons are neutral. So this is a neutral atom. Now, if for any reason the number of neutron changes in the nucleus, for example, if from this nucleus we remove 1 neutron, then this nucleus has 3 protons and 2 neutrons, right? Because it has lost 1 neutron. That can happen. And in this case, this atom will be termed as an isotope. Okay, so this is no more will be termed as a neutral atom. It will be termed as an isotope. Okay, so in an isotope, the number of neutron is less than the number of proton. Now, when this happens, sometimes this nucleus could become unstable because of the loss of balance. You see, before it has three protons and three neutrons. Now it has different numbers of protons and neutrons. So this is an isotope, and most of the cases it doesn't create any problem, but sometimes because of that unequal numbers of protons and neutrons, this nucleus becomes unstable and an unrest can be created in the nucleus, and that may produce or emit radiation. If that isotope emits radiation, that will be termed as radioisotope. Make sense? So if the isotope doesn't emit or release radiation, it is an isotope. But if the nucleus radiates, emits or release energy or radiation, that is radioisotope. That radiation uh, could be very harmful for the living cell, can kill the living cell, and could be harmful. Now, since we know that radioisotopes can kill the living cells, now we can use that radioisotope for medical purposes or to treat some diseases, for example, cancer or tumor. We can use the radioisotope to kill abnormal cells of your body, tumor cells or cancer cells. So you have to use it precisely to kill the tumor or cancer cells to treat the patients. Radioisotopes have other uses too, other medical uses. Radioisotopes are also used as tracers. Use the radioisotopes to trace the organs inside the body or tissue inside the body, and that means the radioisotopes can also be used in imaging techniques or purposes. Radioisotopes can also be used to treat hyperthyroidism. In hyperthyroidism, the thyroid cells uh, become hyperactive or overfunction of thyroid tissue, so you can kill the thyroid cells or tissue in some extent to treat the hyperthyroidism. Okay, so those are few medical uses of radioisotopes. Okay, now let's draw another atom here and the nucleus. So this is the nucleus and this is the shell. Now in most of the atoms the number of shell is more than one. So for example, this one has two shells. Okay, there could be more than two. So this is inner shell and this is outer shell. Okay, and the electrons can be present on both shells. The outer shell is called the valence shell. Okay, and the electrons, those are present on the valence shell, those are called valence electrons. For example, this valence shell has these 3 electrons, so these are valence electrons. Okay, valence electrons. Now, inside the atom, how many atoms inside an atom, how many protons are present? That is the number called the atomic number. So the term atomic number is the number of protons in the nucleus. If this atom has 2 protons, and of course this has 2 neutrons and 2 electrons. Okay, so the atomic number is 2. In this case, the atomic number is what? 2, because it has 2 protons. If this one has, for example, this one, we talked about this before, it has 3 protons, right? So the atomic number of this atom is 3. Now, another term we use that is called the mass, atomic mass. Atomic mass. Atomic mass is protons plus neutrons. So what is the atomic mass of this atom? 4, because 2 protons, 2 neutrons, right? So 2 plus 2. Atomic mass of this atom is 4. However, the atomic number is 2. Now, in an isotope, the atomic mass is different than the atom. If I remove 1 neutron from here, it will become what? An isotope, right? Less neutron in the nucleus. So now if I take 1 neutron out, it has 1 neutron left and 2 protons, right? So the atomic mass is what? 2 plus 1, 3. So in this case, in this isotope, the atomic mass number is not 4, it is 3. Okay, atomic mass is different in an isotope. Each proton has a mass of 1 Dalton or 1 atomic mass unit. AMU is the unit. Okay. Each neutron also has 1 Dalton or 1 atomic mass unit. However, electrons are considered as weightless. The mass is so negligible, it cannot be detected or measured. So weightless. You see, this is an atom of helium and it has 2 protons, red, 2 neutrons, yellow, and 2 electrons, this dark one. So it is neutral. So atoms are neutral. Now, since the electrons orbit the nucleus, move around the nucleus very fast, when you see from outside, it looks like a cloud, and that is called the electron cloud. All atoms have protons, neutrons, and electrons. However, hydrogen is different or atypical. It has only a proton, no neutron is present in the nucleus. So it has a proton in the nucleus and an electron on the shell. Okay, but other atoms have protons, neutrons, electrons, same number. Okay, so we already talked about the atomic number and mass number. We already talked about the shell and valence shell, valence electrons. Okay, we already talked about the isotope and radioisotope. Now we'll talk about a very important uh, component that are produced in the body continuously. Those components are called free radicals. Free radicals are produced inside the body and could be harmful for the body. Okay, so free radicals are harmful for the body. However, they are produced inside the body. The most common free radical is superoxide, called superoxide. It is an oxygen molecule that has an extra electron. You know, electron is negative, right? So this is oxygen molecule, we all know. O2 is, and in free radical superoxide has an extra electron. So an extra electron is present or added to the oxygen and makes that oxygen a superoxide. Now superoxide is a free radical and harmful for the body. However, they are produced in the body. And this superoxide creates oxidative stress inside the body. Okay, and this and oxygen O, and these are the electrons. This one has one pair, two pair, three pair, and this is an extra electron. Okay, so it has one pair, two pair, three pair electrons. So these are paired. However, this one is an extra unpaired. So what happens, this superoxide, since it has an extra electron, it will try to find a molecule where it can bind and give this or share this unpaired electron. So it will try to find the cells in the body and will bind with those cells where it can, and can cause changes in the cell, changes in the healthy cell that it gets attached to, and that can cause the damage of the cell that gets attached to another cell like healthy cell. This is this free electron extra electron will try to get attached to this, and that will cause harm to this healthy cell. Change the DNA, can cause mutation of DNA, and can cause diseases. Okay, so uh, it can lead to death of the cell, or can change the DNA and can cause inflammation in the cell membrane, or damage of the cell membrane, or change the DNA, or damage of the DNA. All these will do what? Will make the cell either very weak, or kill the cell, or change the behavior of the cell. So that may lead to a number of diseases. And in one term, we say that superoxides can cause aging of the cell. Okay, and can lead to many inflammatory diseases like rheumatoid arthritis, inflammation of the joints, you know that. Okay, inflammation of the joints can cause Parkinson's disease or Parkinsonism, atherosclerosis, accumulation of fat inside the artery. Okay. However, some factors can enhance or increase the production of superoxide. For example, environment. Unhealthy environment can cause excess production of superoxide in the body, like certain chemicals, some medicines can cause excess production of superoxide, smoking, pollution, environmental pollution. Okay, if you inhale the toxic chemicals in the air, if you live in a place where you have a lot of factories around your house that produce a lot of toxic chemicals, if you inhale that air, that will enter into your body and cause excess production of superoxide. So what will happen in your body? The cells will get old faster, even when you are not that old. The cells will get older, aging of the cell, and may lead to diseases. However, another chemical uh, that is called antioxidant. Antioxidants can reduce or remove the superoxide from the body. That means antioxidants are good, right? So antioxidants are present a good amount in certain fruits and vegetables that have a lot of carotene. For example, the colorful fruits and veg, they have a lot of carotene to remove the superoxides from your body, will keep the cells healthy. Also, superoxides can be removed by other antioxidants, vitamins. Which vitamins have antioxidants? Vitamin C and E. Okay, and you all know that fish oil has plenty of vitamin E, and fish oil is sold in the pharmacies as omega 369. Very good. Okay. Antioxidants. uh, a chemical that is also produced inside the body, it is called SOD, or superoxide dismutase. So what it does, it removes the superoxide chemical, superoxide dismutase, also in shortcut you can say SOD, and it is also found in the pharmacy. You can buy, can remove the superoxide. Okay, so free radicals are removed by antioxidants. So there are three types of bonds can be formed between the atoms. These are most common types of bonds in your body: ionic bonds, covalent bonds, hydrogen bonds. Ionic bonds are the medium strength bond. Okay, and ionic bonds are formed by formation of ions. How? You see, let's go back to the atoms. You already know about the atoms, right? So this is an atom. It has 3 protons. These are protons, positive, right? So 3 positive, 1, 2, 3. And how many neutrons it should have? 3. Same number of neutrons. So this one has 3 neutrons. Neutral, no charge. So in the nucleus you have 3 positive. Then this one has 3 electrons on the shell. Make sense? Now let's draw another atom. It has 2 protons, so 2 positive. Okay, and of course 2 neutrons, same number of neutrons, and on the shell you have what? 2 electrons, 1, 2, and we know that electrons are negative. So electrons are negative. Okay, when these two atoms come close to each other, if this second atom, this one, has an empty spot for another atom, although there is no atom sitting here, but there is a space or empty spot. For another electron, what will happen when these two atoms will come close to each other? One electron may jump out from this atom and can join here, get attached here. So that can happen. So now what has happened is, see here, this atom has lost 1 electron, right? So now on the shell you have 2 electrons. However, in the nucleus you have 3 protons. So the number of proton is more than the number of electron, because this one has lost 1 electron. So this will become what? Positive. No more neutral, right? Because plus is more than minus. And what happened here? This atom received 1 extra electron on the shell. So now it has 3 electrons on the shell, however 2 protons positive in the nucleus. So it has 1 more extra electron. So it will become negatively charged atom, right? So first one will become positively charged atom, which is called a cation, and the negatively charged atom is called an anion. Okay, negative is anion, positive is cation. So now both are ions. So cation is positive ion, anion is negative ion. So we can say by donating or losing and receiving or accepting electrons, the atoms will become ions. If the atom loses electron, it will become cation, positive. If the atom receives electron or accepts electron, it will become negative, anion. Okay, and since one become positive and another become negative, they will do what? Attract each other to form a molecule. So by joining these two, a new molecule will be formed from these atoms. So that is called the ionic bond. So here you see this is sodium, okay, and this is chlorine, Cl, and sodium. On the valence shell, uh, it has electron, and this electron from the valence shell of sodium jumped to this empty spot here. You see there is a spot, empty spot. So when they will come close to each other, this electron will jump from here to here. So this is what happened in this side. You see this one has lost the electron, so it will become positive, and this one has accepted the electron, so it will become negative. So sodium will become positive, neutral sodium will become cation, and neutral chlorine will become anion, negative ion, and they will attract each other to form what? Sodium chloride, the salt molecule. You all know that. Okay, so this is called the ionic bond here between plus and minus. Okay, another type of bond between the atoms is called the covalent bond. This covalent bond is the strongest bond in the body. The covalent bond is formed not by donating or accepting electrons, but by sharing the electrons. What is that? This is one nitrogen atom. This is another nitrogen atom. When these two nitrogens uh, atoms will come close to each other, what happens? You see, these valence electrons, these three and these three, they will get attached to each other here. So these three paired are now being shared between these two atoms. Okay, and since they are attached to each other, they are being shared between these two nitrogen atoms, and this bond is very strong. This attachment is very strong between the shared electrons, and this is called the valence bond. Okay, and we indicate the valence bond by the lines. Here three pairs of electrons are being shared, so we indicate by three lines. Okay, so how many electron pairs are being shared, we indicate that by the lines. That's why in many chemical formulas you will see like C, C, that means two pairs, or C1, C. Okay, how many pairs of electrons are being shared in that valence bond, strongest bond among those. Uh, Another type of bond that is called the hydrogen bond. The water molecules of your body are connected to each other or attracted to each other by the hydrogen bonds. And you know that most abundant chemical in the body is the water. So the water molecules are staying together because of the hydrogen bonds. Hydrogen bonds are weak bonds. However, they can hold the water molecules together. Now you know water is H2O, right? 2 hydrogen, 1 oxygen. So let me see here. This is H and these two are oxygen. Okay, so H2O. So in hydrogen atom, uh, so this is one water molecule. So this is H, which is positive, and O, negative. Sorry, H2O. So these two are hydrogen, positive, plus hydrogen, H, H, and this is O, negative. Okay, so this is one water molecule. This is another water molecule here. Okay, H2O. Okay, so these are positive and this is negative. Okay, so when these two molecules, water molecules, come close to each other, what happens? You see, this is negative oxygen and this is positive hydrogen. This is negative, this is positive. So they will attract each other. And this is negative oxygen will attract the hydrogens. Okay, so the positive and negative will attract each other, and that is hydrogen bond. Okay, water molecules are connected to each other. How you know that? There are many examples you can see. So here again, what I showed you: oxygen weakly negative and hydrogen weakly positive. Okay, so they will attract each other, and that is the hydrogen bond. Now, how we know that water molecules stay together? Good example is sometimes you'll see on the surface of the water in a pond or somewhere, the small flies, they can easily sit or walk. That is the surface tension of water created by the hydrogen bonds. The molecules stay together, connected together. Another thing you can do, you can put your finger in water and take out from the water, and you see a nice ball of water is formed uh, on your fingertip. That means the water molecules try to stay together, and when the water drops, the whole drop, you know, of water drops at once, and the molecules are staying together. Chemical reactions. So those are three types of bonds: covalent, then ionic, and hydrogen. Covalent, ionic, hydrogen. Ionic is formed by donation and accepting electrons from the shell and by forming ions, positive and negative ions. Covalent bonds are formed by sharing the electrons on the valence shell, and hydrogen bonds are formed by between the water molecules. Oxygen negative, hydrogen positive. Now, chemical reactions. Many chemical reactions take place inside the body, you know that, and we can group those chemical reactions into three main types of reactions: synthesis reactions, decomposition reactions, and exchange reactions. Synthesis is also called combination reactions. Synthesis reactions form larger molecule from small molecules. So from small molecules to a larger and more complex. From simple small molecules to a larger and complex molecule. Okay, and synthesis reactions occur inside the body mainly to store the chemicals. Store the chemicals. Storage. Decomposition is just opposite of simple. That means from larger and complex molecule to small and simple. So just opposite. And decomposition reactions usually occurs not to store the chemicals but to utilize the stored chemicals, to release the chemicals, to produce energy or ATP. In exchange reactions, the parts of the participating molecules are exchanged. So the parts are exchanged between the two molecules. So let me give you an example of synthesis. You know that glucose molecules are very small. So these are small glucose molecules. Most simplest and smallest carbohydrate molecules are glucose molecules. Now, if you take too much glucose in your food, some glucose will be used for metabolism to produce ATP energy. However, the excess glucose will be stored, okay, by synthesis reaction. So these small glucose molecules will get attached to each other to form a single complex molecule. So you see here many small glucose molecules join together to form a complex larger molecule. So this is one molecule now, which is larger and more complex, and this is called glycogen. Okay, so this is a synthesis reaction, and glycogen will be stored in your liver or skeletal muscle as a stored form of glucose or carbohydrate. Decomposition is just opposite. If you break the glycogen from the stored source, then this glycogen will release the glucose, and that can be used to produce ATP by metabolism. Okay, so this is decomposition. Okay, opposite of synthesis. Another example could be amino acids. Amino acids are the units, small units of protein molecule. So these are amino acids. Okay. So if you combine these amino acids together to form a chain, this is a protein molecule. How they join to each other? By peptide bonds. Okay. So this is one molecule of protein. It has a number of amino acids. Okay. So this is a synthesis from small amino acids. One large protein molecule is formed. So synthesis. Now if I break the peptide bonds, then what will happen? Decomposition of protein will occur. It will break into small amino acids. So this is decomposition. So these are two good examples of synthesis and decomposition. Now the exchange reactions, two molecules, for example, sodium hydroxide, NaOH. This is one molecule of base, and this is hydrochloric acid, HCl, hydrochloric acid. It is an acid. Okay, when these two molecules will react, reaction will occur between these two molecules. What will happen? This sodium and this chlorine, they will join to form sodium chloride, which is a salt. The salt you eat, one salt molecule. And this HO and this H, they will join together to form H2O. What is this? This is water, right? One water molecule. So you see, this is a base, this is acid, hydrochloric acid, and these two molecules, one molecule of base and one molecule of acid, they will exchange their parts, okay, to form a salt molecule and water molecule. So this is a very good example of exchange reaction. Okay, so those are different types of chemical reactions occur in the body. In your body, you have both organic and inorganic compounds. The inorganic compounds are water, salts, many acids, and bases. Okay, water is the most abundant inorganic compound. Water is also the most abundant uh, among both organic and inorganic together. So those are inorganic. Organic compounds are carbohydrates, fats, proteins, and nucleic acids. Okay, and inorganic compounds usually do not contain carbon, but organic compounds contain carbon. The properties of water. Since water is the most abundant chemical in the body, 60 to 80% of the volume of a living cell is water. So water is the main component of the body or living cells of the body. Water has some important properties. One is called high heat capacity. Water, a small amount of water can hold a lot of heat in it. Okay, and that is very helpful. When body temperature increases, sweating occurs, and that small amount of water that gets out from the body takes a lot of heat out from the body and cools the body, lowers the body temperature. Okay, that is very helpful. So this property is very helpful. High, high heat vaporization. Water will not be quickly turned to vapor or air, which is very helpful for the body because your body is mainly water, right? The cell's 60 to 80% volume is water. So if water quickly leaves the body, then the whole body will shrink. The cell will shrink significantly. That will cause severe problem or consequences. So to turn the water to vapor, you need to give lot of heat. Okay, it will not easily be uh, converted to vapor, which is very good. Otherwise, you will lose the size of your body, shrink the body quickly. Uh, body's major transport medium. You know that blood contains a lot of water, and blood transports most of the chemicals from one place to another in the body. So water is the main transport medium. In many chemical reactions, water directly or indirectly participate. So, for example, in hydrolysis type reactions and dehydration synthesis reactions, water participate. Okay, or directly or indirectly. In some chemical reactions, water uh, directly participate. In some reactions, water indirectly participate. Uh, and that cushioning is another important function of the water. Around your brain, you have cerebrospinal fluid, which is mainly water to protect your brain. Another fluid around your heart is called the pericardial fluid. Pericardial fluid. Around the lung, you have pleural fluid. Around the abdominal organs, you have peritoneal fluid. Okay. In the joints, you have synovial fluid. So these are mainly water, and these fluids protect your organs. Acids and bases. Quickly, I'll talk about the acids and bases. Acids are the chemicals that can quickly release or donate hydrogen ion. For example, hydrochloric acid. Why it is an acid? Because it can quickly release the hydrogen ion. Okay. Uh, sulfuric acid or carbonic acid, H2CO3. Carbonic acid, why it is an acid? It can also quickly release hydrogen ion. Okay, so both are acids because they can donate or release hydrogen quickly. If this one can give more hydrogen than this one, then this will be stronger acid, this will be weaker acid. So which one can give more in a single unit of time? That is the stronger acid. Bases do what? Quickly remove the hydrogen. So opposite. Okay. Then the acid. Good example of base is sodium hydroxide. This is a typical, most common base. And how this one removes hydrogen ion? What happens? The sodium hydroxide, this base, will quickly split and release OH. So base must be able to quickly release OH to do what? To remove the hydrogen ion. Now, when the hydrogen is released from an acid, for example, this is hydrochloric acid, it quickly releases hydrogen, right? So this hydrogen can be quickly removed by this base. How? This base will quickly produce OH, and that will bind with this hydrogen and will form water, H2O. So these two will quickly join to each other and produce H2O, which is neutral. You know that, neutral water. So you see that base, by producing OH, can quickly remove the excess hydrogen ion, and that is how the base works. pH is negative logarithm of hydrogen ion molecules, and this relationship is very important. The concentration of hydrogen ion, if the hydrogen ion concentration increases, the pH decreases. So more hydrogen ion means less pH in that chemical, okay, and that means acidic. So remember, this is a very important link. You need to remember it. If in your body more hydrogen is produced more than normal, then the pH will be lower, and that will produce the body acidic, and that is called acidosis. So that's why you need to know this, okay? And the neutral pH is water, 7. Water is neutral and the pH is 7.0. If the pH is less than 7.0, that is acidic, and if it is more than 7.0, that is alkaline. Okay, so between 0 to 6.99 acidic, 7 is neutral, and from 7.01 to 14 alkaline. Okay, above 7 is alkaline, below 7 is acidic. Okay, here you see the pH meter. So 7 is neutral, and above 7 is alkaline, and below 7 acidic. As you go more and more, uh, below 7 becomes more and more stronger acidic. As you go more above 7, it becomes stronger alkaline. So here are some household chemicals or foods that we use every day, and their pH. Okay, so those are the acids and bases. Now the organic compounds are carbohydrates, fats, proteins, and nucleic acids. Carbohydrates could be 3 types: monosaccharides, disaccharides, polysaccharides. Simplest form is monosaccharide, and the best example is glucose. So glucose is the simplest and the smallest carbohydrate molecule. Okay, disaccharides, maltose, 2 monosaccharides joined together to form a disaccharide, and polysaccharide is the most complex and largest. Examples: starch, glycogen, glycogen. These are most complex and larger carbohydrate molecules, and these are mainly stored forms of carbohydrates. In carbohydrate molecule, you will find CHO, those three atoms. Lipids, a lipid molecule usually has CHO2. However, sometimes in lipid you will also find P, phosphorus. Insoluble in water, and three main types of lipids found in the body are neutral fats, also known as triglycerides or TG, phospholipids, and steroids. Okay, triglycerides are mostly present in the blood. Phospholipids are mostly found in the cell membranes, and steroids are mainly found in the hormones, steroid hormones. Okay, now the fats or fatty acids could be two types: saturated and unsaturated. Saturated, why it is called saturated? Because it has plenty of hydrogen, saturated by hydrogen. In unsaturated, you have reduced or less amount of hydrogen present, not saturated with hydrogen. Now, in case of saturated fatty acids, the carbon atoms are connected by single bond. That means one pair of electrons. So like this. In unsaturated, you will see single as well as double bonds, okay, between the carbon atoms. Now, a few things about saturated and unsaturated. Saturated fatty acids mostly come from animal sources. Animal sources. So animal fats are saturated, and saturated fatty acids are harmful, could be harmful for the body, because the saturated fatty acids can accumulate inside the artery and can cause narrowing of the artery, or even can block, and that is called atherosclerosis. Okay, and saturated fatty acids in normal room temperature uh, stay solid. For example, butter or cheese, those are butter, those are saturated fatty acids, and in solid form in room temperature. Okay, unsaturated fatty acids are also called healthy fat, and mostly come from plant sources, okay, and present in liquid form in room temperature, okay, and not harmful, okay. Proteins. In a protein molecule, you will find CHO, however, also an N, nitrogen. So in carbohydrates and fats, you have CHO but no N, but in proteins you have nitrogen too. Now protein molecule has two groups. In each protein molecule you have amino group and carboxyl group. COOH is carboxyl and NH2 is amino group. You already know that protein is formed by amino acids, right? So amino acids are the building blocks of proteins. There are 20 amino acids human body need. The human body needs 20 different types of amino acids. 10 of them are produced in the human body, those are non-essential because they are being produced in the body. Other 10 you need to get from outside with your food, because your body cannot exactly produce those. So those are essential, you have to get from outside. Now the source of energy is ATP. So we know that metabolism produces ATP in the body, and ATP helps in many functions in your body. Here you just see few examples. This is a cell membrane, and in the cell membrane you have channels. To open some of those channels you need energy, and ATP gives that energy to open the channels or doors. To open the door you need to push, right? So ATP releases a phosphate, and that will serve as an energy to open the door. Here you see this P came from ATP. So ATP will split and release a P and then ADP. This is adenosine triphosphate. Tri means 3, P. And here diphosphate 2. So one phosphate is released here. Okay, and this one will give energy to perform the action. Also, this causes the contraction of the muscle fiber. You see here, bring the molecules close to each other for the chemical reactions. For chemical reactions, the molecules must come close to each other, right? Otherwise, no reaction will occur. So this P will bring the molecules close to each other to cause the chemical reactions. Okay, so that's how the energy is released, and it helps in many functions, physiological processes in the body. Okay, so those are the things you need to know from the chemistry of life or chemical level of the body. Okay, so today you have learned the atoms, right? And also you have learned how the atoms form the molecules, and you have learned about the compounds. You have learned about the structure of an atom, and how an atom, neutral atom, is converted to an isotope, and how some isotopes become radioisotope, and the uses of radioisotopes in the body in medical science. You have also learned about the atomic number, atomic mass, right? And how the bonds, 3 types of bonds are formed. Covalent, the most strong bond. You have also learned ionic bonds and hydrogen bonds between the water molecules, hydrogen bonds. You have learned about 3 types of chemical reactions: synthesis, decomposition, and exchange reactions, right? And you have learned about the proteins, carbohydrates, fats, and energy, how the ATP works. So those are the main things from today's lecture. Thank you very much.